Hey guys, this is section 11.9, representations of functions as power series. This is an incredibly short and very tiny section, so we're just going to talk about it kind of overall and look at one example. And then there are two or three more in the book you can take a look at, and then the homework is only 3 questions. It's all very, very similar to the example in this presentation. This is not really one of the vital sections of this chapter, but since we have the time before the next exam, we're just going to take a look at it at a high level. So the first thing we're going to look at is a geometric series that we've seen, I think in 11.2 is when you first saw this series, just the sum of x to the n from n equals 0 to infinity. And we saw back then in section 11.2 that if you work this all the way out, that the sum of this series ends up being 1 over 1 minus x. So the sum from n equals 0 to infinity of x to the n is 1 over 1 minus x. And like I said, it's a geometric series where a is 1 and r is x. So in this section, though, we're going to focus on the fact that this is that this function, 1 over 1 minus x, can be represented as this power series, and then use this as a jumping off point for how to represent other functions as the sum of a power series. So we're just going to jump straight into that example. All right, so this example is to express 1 over 1 plus x squared as a power series. So our one example that we have before this is 1 over 1 minus x, and we know exactly what that looks like. So any other function that we want to try to make look like a power series, we need to always go back to this form of 1 over 1 minus x. So in this example, the difference is instead of minus x, we have plus x squared. So in order to make it look like 1 over 1 minus something, we need to switch it to minus a minus, which of course we know is plus. So 1 over 1 minus negative x squared makes it look like the form 1 over 1 minus x. So instead of x, we use negative x squared. Now, again, sorry for going back and forth so often, but 1 over 1 minus x, this x becomes the power series, x to the n. So we replace x to the n with negative x squared to the n. And then we have a power series that exactly represents our function, 1 over 1 plus x squared. Now, in order to find the interval of convergence, though, we have to keep going. Okay, so first off, we don't want to have the negative or the squared inside the parentheses with this n. We want to separate it out so that we can figure out how to find that interval of convergence. So we pull the negative out to make it a proper alternating series so that we can have the positive term by itself. And then what's left? X to the 2n. Where does that come from? X squared raised to the n power. Remember, the way you combine those exponents is with multiplication. So this is 2 times n. So we have x to the 2n left over after we pull out that negative. And then here's just the first several terms of that sum so that you can understand what it fully looks like. Okay, and this is still a geometric series, which means we know it converges whenever the negative x squared term is less than 1. Why do we know that? Because in our original series, we know that converges when the absolute value of x is less than 1. So in our example, that would be the absolute value of negative x squared instead of just x, because that's the substitution in this example. Well, when you apply an absolute value to a negative sign, of course, that negative just goes away, and x squared is always positive. So you can completely drop the absolute value and the negative sign and end up with only x squared is less than 1. And what does that mean? That means the absolute value of x is less than 1, because x could be positive or negative and satisfy this inequality as long as it's less than 1. Okay, so what does that tell us? X squared less than 1 turns into the interval negative 1 to 1 with parentheses around each side. So our big R, our radius of convergence is 1, and our interval of convergence is negative 1 to 1 because it's a power series centered around 0. And that is it for this section.